just use plaster.
The one plaster has more protection against.
You're only doing a tiny little strip. How much?
You do the whole wall.
You don't cover the whole wall.
Yes, you do. You do.
It's essential that they become independent learners and start to manage and control their emotions and the way that they learn and the way that they think.
That's what the one plaster's for. Oh my god.
In this game, it's all about collaboration and project management. Okay, the engineering is one part of a much bigger picture. Okay, so work through that together.
It's just pointless. I'm just.
Our task was to work with the engineering firm Norman Disney & Young to create a sustainable 5-storey office building in the Docklands. The building that we came up with, we called it E2. E2 for excellence and efficiency.
By having energy efficient cooling, heating, well, appliances, TVs, computers, will cut down our carbon emissions for the future.
It is the largest construction project currently in Victoria in terms of building services construction. It's got a construction value of $1 billion.
Well, at the site visit, we kind of went around to grab ideas for how they incorporated energy efficiency in their hospital. So then, we took some ideas from what they did and then put it into our buildings.
We've worked with fire engineers, mechanical engineers, hydraulic engineers, environmental sustainability engineers, and electrical, did I say? So things that we weren't quite sure about, they have been answering our questions pretty much.
And stuff have to be separate to each other. They can't be the same.
That's why you would have a
supermarket and cafe.
Supermarket would
be
all.
And then you go.
And then you have your waterfall in the back, yeah?
That's the front there.
That doesn't look like
That doesn't look big. Look at the guy's height. That's
one.
As you come in, there's a turnstile, so that can be accessed by public, so you can come in. The second building is the gym room. Now this gym room only employees can use, and the actual bikes and the treadmills, when people are using them, they make electricity.
Doing the calculations for the average watts computers and laptops use, and then I'm gonna times that by how many laptops we'll have in the office to get kind of an estimation of how much energy we're using and how much energy we're saving.
To ensure that the building had, was structurally sound, to ensure that there was the correct amount of heat, or if heat was being lost, they had to do lots and lots of calculations.
There's the equation here where it's to find out how much power we're using by timesing the voltage and the current, the electric current together, and to find out how many watts we're using. We've got a 3-phase electrical system that we're using in our office. So the equation for that would be power equal to 400 times the square root of 3 times 25, and then times the number that the energy.
With the cooling and heating, you need to know about particles and about how with heating they expand, so they rise, and with cooling how they become more dense. We've learnt a thing called heat transfer, so from the heat from the middle of the room to the outskirts of the room, and then from the heat from the outside, from the sides of the room to outside. We've need to learn about the different sorts of materials that we can use, such as the concrete, and in comparison to say plastic, the concrete absorbs the heat a lot more slowly, being much more dense, and releases the heat a lot more slowly as well in comparison to plastic. With tiles, we're using stone, preferably granite. There is a bit more of a cost, but its thermal efficiency makes up for that in energy costs. It absorbs the heat and releases the heat much more slowly.
Yeah, we're going to go for an evaporative cooling system, but we figured that the humidity in that air wouldn't make it a comfortable working environment. So we decided to go with the chiller combination. With that, the chiller combination, the air is not as moist, and so it won't. Because with evaporative cooling, it forms like you get sometimes mold forms in the building because of the water, the moisture in it. So with the air-cooled water chiller, it just chills the air as it goes through the system. So there's hardly any moisture in the air.
So E2 is made to influence the behaviour of the employees inside. And so one of the points is we'll have clearly identifiable recycle bins, so they know where to put their recycled waste. The stairs will be located in front of the elevator to encourage people to use stairs rather than the elevator.
Electronic floor panels. These floor panels will be located in the front entrance and on the stairs. What happens is when people walk over these floor panels, they create a small amount of electricity, which is also stored with the other kinds of renewable electricity and distributed throughout the building.
We chose this location as it's very close to multiple kinds of public transport. We also gave it a smaller car park to encourage alternative, environmentally friendly transport, such as the public transport. We've also tried to harness the wind, the heavy winds and the solar energy that comes with the docklands, and we try to use this to harness our own renewable energy.
We're going to be using T5 fluorescent lighting, and these are going to be centered all around the building, as they save much more lighting than the T8, which produces the same lighting but uses more electricity. These are going to be controlled by sensors placed around the perimeter to control the lighting. So if it's sunny outside, then the lights will dim automatically, and if it's dark outside, then the lights will brighten.
And the only water that is sent to the sewer is black water, and we use vacuum toilets anyway, so only small amounts of black water into the sewer. So our building effectively just reuses all of its water.
So the exterior of the building is made of ETFE, which is a new technology plastic, and it reduces the energy cost of the building by up to 30%, as it lets light through, so it reduces the cost of the lights. Here's the front, that's all ETFE, that area, and here's the entrance to the atrium with the spin door at the front. See all the desks of the workers, and as you can see, the side solar panels are along there, and the heater. Spin around. There's the wind turbines, and here are the see-through solar panels that are used for the top of the atrium, which will effectively reduce the heat, so we can control the temperature of the atrium.
The way that I'll take this back to schools, I'll see how the comparison in the working environments, it's a lot more, you need a lot more maturity here, and we notice that straight away. Even talking to our friends when we get back home, you can see the difference in maturity and how much we still need to grow as people.
I think they learnt that they were responsible for their own actions. That was probably the main one, so that nobody else was going to do it for them. And maybe in a school setting, I think that can happen. You know, that the going gets tough, there's always someone there. There's a home-based teacher, there's a science teacher, there's the vice principal. Someone can interface and work things out for them, or their parents often will fix it for them. But here they had to actually solve their problems within the group and solve their knowledge problems themselves within the group, or by asking an expert and then taking that back to the group. So that's quite different from being in a school.
What I found with working in the team is that everybody is different, everybody has their different ideas, and I think that's what made this team so special. Able to bring in our own ideas and make this building really our own was probably the best part of this project. And being treated like an adult, which we find much better than being treated like kids at school. Higher expectations of you here in an office-like environment.
It's just been a good experience just to interact with adults and hear what they have to say, and they hear what we have to say on the other side, and they guide us along the way as well, just for any problems we have.
It kind of felt like we were part of the company and stuff, because we kind of got treated how everyone else got treated that worked there. And since we got to walk around, we felt like we were an asset to the company.
When I leave school, I want to become a fire engineer.
When I leave school, I want to be a hydraulics engineer.
When I leave school, I want to be a mechanical engineer.
When I leave school, I want to be an electrical engineer.
When I leave school, I want to be a robotical engineer.